Okay, I think we are ready to go. Hi, my name is Ian Mackenzie. I am the Principal Geotechnical Engineer in the Welsh Government. Thank you for joining us today's webinar, supported by Syria's new Geospatial Community of Practice to explore sustainable water management using spatial data. Right, before we begin, I would like to cover a few housekeeping points. Right, today's webinar is being recorded. The presentation and recording will be made available at a later date. All attendees are in listen-only mode. So please raise your hand or send a chat message if you have any problems with your connection or audio, and one of Syria's team will help. We do have a dedicated Q&A session after the presentations. However, during the sessions, please type your questions in the Q&A box, and please state if you wish to direct your question at a particular speaker. We will be monitoring the questions as they come in. If you can click the thumbs up to like other attendees' questions, this helps us identify the most popular questions. Also, please feel free to share resources in the chat as well. We are keen to hear about your webinar experience and would be grateful if you could complete the short poll at the end of the webinar. Also, if you want to receive CPD for this event, you need to complete that poll. And please share your views and experiences with us, the hashtags at the bottom of the screen there. We aim to finish about 12 o'clock today. Okay, so let's start with a quick overview on who Syria are for those who aren't fully aware. Syria is a not-for-profit, members-based organisation with over 60 years' experience in promoting good practice. Our core strength has always been improving performance through collaboration in the built environment and construction sectors. Syria organise around 50 events per year, mostly online at present, ranging from topical conferences, annual debates and lectures to webinars on our guidance, such as today's topic. In the areas of sustainable land use, Syria has published over 55 good practice guidance and run over 200 events over the last 2 decades. We've developed an app and shared resources through web portals. Syria has delivered other independent guidance documents such as the SUDS manual, the ROC manual, the International Levy Handbook, and Biodiversity Net Gain. They also have a strong legacy of asset management and geotechnical guides, including the embedded retaining walls, hidden defects in bridges, structural health monitoring, UAVs, non-destructive testing, and most recently, GIS for infrastructure. Syria is a small but growing organisation. We've got about 80 members, which you can see in the slide, and it's really good to see lots of people here today. They also have lots of thriving communities of practice to identify priority topics, and they facilitate the co-design the delivery of other projects, and they celebrate the successes via prestigious awards. So at the moment, the Syria communities of practice, the biodiversity, build off-site, driving net zero carbon, geospatial, PFAS, soil, and sustain. Okay, so I'm here today as the current chair of the Geospatial Community of Practice. As I say, I work in the Transportation Department of the Welsh Government. I'm a geotechnical engineer and I'm an asset manager. I work mainly in the Strategic Road Network and Highway Department. So undoubtedly, as an asset manager, the main challenge that I face is developing asset resilience in the face of climate change. So really protecting earthworks for the next generation. And really at the moment, it's all about asset adaptation. So trying to improve what I've already got. And that type of change is only really possible with network scale information. and that's why I'm involved in the community of practice. I'm very keen to promote INSAR, Earth observation, and just general geospatial analysis. I mean, I do it essentially because I like the outputs. I like the maps, the images, the real measurements that can be reviewed and interrogated and analysed, and it's all possible to do at a network-wide scale. So this community of practice, it grew out of two recent Syria guidance reports, one on GIS for infrastructure and the other on INSAR for civil engineers. Membership includes organizations from the public and private sectors. So it is a mix of asset owners, engineers, satellite data specialists, consultants, professional associations. Oh, sorry, gone too far. Yeah, so the community of practice, it is really about collaboration and knowledge sharing. So we're trying to highlight the key challenges, showcase examples of where Earth observation has been used and applied and the overall benefits. And it's really about showing that you can take the raw data all the way through to the client's asset management systems to derive the maximum benefit from what it is possible. Okay, so what brings us here today? So working with Earth observation data is no new concept in the water utility sector, and great steps have been made to enhance the use of the data and solutions in recent decades. However, in an ever developing digital environment, there is an opportunity to collaborate and educate industry at a base level, providing people with information to encourage the use of Earth observation data and giving confidence to first-time users or infrequent users. So we're going to explore how well integrated Earth observation is within the water utility sector in the UK and discuss how this can be developed. I'm going to try and pose questions such as, how does Earth observation influence the sector? What data is available? What can it be used for? Where can I get this data? And what are the challenges to be expected? So I'm delighted to be joined by today Dr. Jennifer Schooler, Head of Product at SatSense, John Houghton, Senior Geospatial Engineer at United Utilities, Tali Barkunsky, Product Manager at Acetera, and Jack Lonsdale, Discipline Lead at Geospatial Stantec. As I say, please type any questions you have into the question box, and we'll pick them up in the discussion as we go through. And also, if you can remember to put the thumbs up to like other attendees' questions, this really helps us identify the most popular ones. So let's begin with the first presentation, geospatial data within dam systems and pipelines. And that's from Dr. Jennifer Schooler, Head of Product at SatSense, and John Houghton, Senior Geospatial Engineer at United Utilities. Good morning.
Hi, thank you. Hi, I'm John Houghton, Senior Geospatial Engineer at United Utilities. I'm responsible for geospatial data capture, which includes topographic, utilities, and drone surveys. And I also manage deformation monitoring of a large number of impounding reservoirs. Right, so at United Utilities, we deliver water and wastewater services for over 7 million people in the northwest of England. Our purpose is to provide great water for a stronger, greener, and healthier northwest. In the delivery of these services, we manage 56,000 hectares of land, 170 reservoirs, hundreds of treatment sites, and thousands of kilometres of pipes. And we manage these assets over the areas of Cumbria, Lancashire, Greater Manchester, Merseyside, and Cheshire. And given the geographical spread of these assets, satellites can provide many benefits, which include large-scale data capture and obviously frequent acquisition of data in a method that is safe and sustainable and also provides a uniform data set. And this allows repeatability of data, which enables comparisons to be made between different data acquisitions, which is essential to monitoring. The satellites are more efficient compared to drone surveys and topo surveys in certain circumstances, as land and airspace permissions are not required, and also we are not disturbing any landowners or our customers. And this means that we can target our resources effectively. Retrospective data assessment through data such as INSAR allows us to look back to 2015 to assess how our assets have behaved over this time, which is a real benefit, because if we're undertaking deformation monitoring of, say, a reservoir, we can only start the clock counting once we've actually established the monitoring system and put it in place. And this obviously takes many sort of weeks or months to actually build up a picture of what's going on, even though we may be seeing concerning sort of features in terms of settlement or perhaps cracking in certain structures or assets. So being able to have an initial assessment and see and look back potentially up to 2015 is really, really helpful. Can we move on to the next slide? Thank you. So we've used INSAR for several years at an impounding reservoir, and it has become part of an integrated monitoring system using precise leveling, monitoring total stations, laser scanning, and tilt meters. And the reason for monitoring rates of settlement at reservoirs is to ensure that the rate is within the expected range. So as you can see in the image in the bottom right, obviously that's a basic interpretation of an embankment, and we're ensuring that the rates of settlement on the crest, i.e. the top of the embankment, is effectively settling at an anticipated rate, because effectively the clay core in the center of that embankment is providing the impermeable barrier to prevent water from moving from upstream to downstream. And the annual rates of settlement measured by INSAR were similar to those shown in precise leveling. And as I've previously mentioned, the retrospective data assessment is very valuable, because what happens is when we're undertaking sort of traditional monitoring through precise leveling, it tends to be focused on the crest or perhaps the upstream of the embankment in question. And what INSAR does is it allows us to understand other areas of that embankment, and also in effect the local topography and how it's kind of like keyed into the embankment. So we gain a view of what, say, the toe of the embankment effectively on the downstream slope is doing, and potentially the upstream, and also tying into any precise leveling that we also have on the crest, which and the method of which Jenny will run through shortly. Further benefits can be gained by installing actual reflectors, which will pinpoint the data that's being provided. Also, satellite imagery. Sorry, if we can go back a slide. Also, satellite imagery and INSAR helps us to protect our assets by understanding their proximity to hazards, and we can do this using imagery and INSAR. For example, river erosion can undermine and collapse pipes, causing supply and environmental loss. And being able to assess rates of erosion allows proactive management and pipe diversions to be made. And this avoids us reacting to incidents and saves environmental damage and the associated financial and reputational loss. So as you can see in the top right-hand image, we have multiple images over time showing how that riverbank effectively is eroding in a direction towards our asset. And so it gives us that visibility. And also, as you can imagine, we have many thousands of assets in the ground. So being able to sort of send limited resources to all of these is impractical. So at least using satellites, we can identify areas of interest. And also being aware of build over development can avoid damage being made to our pipes. So for example, large diameter pipes can have an easement of up to 5 meters from the pipe center line, and damage caused by development can cause significant disruption to supply. And we could also use the impact of ground settlement or potentially leakage on the surrounding ground, and also on third-party assets to see have any changes in effect been caused to that environment. And my colleagues in water operations have also had positive trials using SAR with regards to identifying leaks on our pipes and locating undocumented consumption. But again, I won't go into this into detail because I think another presentation covers that. So we could go to the next slide, please. Okay, so just briefly, so in terms of opportunities, there's certainly more opportunities to further integrate satellite sort of INSAR data and imagery into our systems to provide effectively an integrated kind of systems thinking approach and be able to share the data through platforms more widely. So currently we're receiving INSAR data using QGIS, and this effectively is a bit of a limiting factor in the sharing of data. And then obviously if going forward, improving enhanced AI and machine learning would speed up effectively the assessment of the data and give us more rapid outputs. And I'll pass you on to Jenny. Thank you.
Thanks, John. So for my section of the presentation, I'll dive a little deeper into what INSAR monitoring is and a case study example with United Utilities. So to start off with, this is an example of a fairly typical INSAR map. So INSAR is an active remote sensing technique, and that means the satellites are actively sending a pulse down to the Earth and then recording information from that return signal. And what that means in practice is, unlike optical imagery, it's not limited by cloud cover or daylight, so it can continuously operate on a revisit cycle. That's typically every 6 to 12 days, the satellite acquires an image of an area in the UK, so roughly 30 times or so per year. And all these points on this map here have a time series associated with it. So as John said, often we go back to 2015, which is when the European Space Agency Sentinel-1 satellites launched. In this case, on this image, I've got back to 2021 with some high resolution X-band data. And the colors on the map, so red is typically movement away from the satellite and white areas are stable. So for the points I have selected here, towards the center of this dam crest, you can see about 20 millimeters of displacement over that 3-year period. So you can think of them as a map of millions of GPS-like data points. There we go. So across the water utilities sector, there's a number of different applications of INSAR. I'll focus on dams and reservoirs in this presentation, but also for pipelines and distribution networks. So the type of things we're looking for with regards to monitoring pipelines is for differential settlement, which can cause strain and potentially cracking of a pipe. Also for pipelines that run through areas with slopes. So we're looking for things like slope stability issues that could cause a problem for the pipelines. And then in terms of kind of future infrastructure, again, INSAR is a very helpful technique at that desk study stage for planning pipelines or new tunnel routes. So having that archive of data going back 10 years, looking for areas with potential instability and what that means for your pipeline route. And with kind of whatever we're monitoring with INSAR, there are 3 main questions that we're typically trying to answer. So where and on which asset is movement occurring? What is the magnitude and spatial extent of this movement? And how have or are the dynamics of movement changing through time? So again, that wide area capability, along with that historical archive and continued monitoring, are the key to answering these questions. So with regards to dam monitoring, this is an example of an earth embankment dam with a clay core. And just to explain a little bit of the kind of INSAR nuances in this image. So the satellites look not purely vertical, they look along the satellite line of sight, which is typically about 30 degrees from vertical. And as they orbit in a polar orbit from north to south and then south to north, we have the descending orbit as they move from north to south and the ascending orbit as they move back up. And this gives us these two look directions at any site on the ground. So in this first image, I've got the descending line of sight here, which you can see is picking up subsidence or movement away from the satellite at both the crest and the upper slope of this dam. And what we observe here is a long-term kind of continuous movement pattern. So you can see over 10 years, it's fairly significant, tens of centimeters of movement. But these, clay core embankment dams are expected to move. But what's interesting is these periods of acceleration and correlating that with things like water levels and other activities that have been ongoing in the dam. And it's these periods of acceleration or deviations from the long-term trend that are what we're looking for when we're actively monitoring and alerting on a dam like this. If we look from the other satellite line of sight, one slide, we can see at the toe of the dam from the other line of sight what looks like heave, but is actually kind of translational outward movement. Again, this long-term trend of movement, but periods of acceleration. And the hypothesis here is these periods of acceleration are correlated with water level changes in the dam. So this general trend is this translational movement down slope at this site. And so in terms of monitoring, how is this data used? Well, every time an image is acquired, so in this case, it's every 6 days over this location, the data's been updated. And what we do is every month run our early warning system algorithms, which look for changes or deviations from the long-term trend. And these alerts are configurable in terms of the displacement threshold that's set. So, that's something we consult with the asset owners in terms of what level of displacement is a potential concern. And also things like how many points are showing this movement. Potentially, if it's 1 point, it could be anomalous. But if a collection of points are showing the same trend, then it's more reliable to be a potential issue. So every month, this is run. And if there's anything that exceeds a threshold, an email is sent to our client, and they can respond and take a look at the data in more detail as appropriate. So just to summarize, some of the key points of INSAR for dam monitoring. So this remote monitoring capability, so using satellites that are already up there, no need to get permissions or boots on the ground to fly or enter the site. That retrospective capability, so going back at least 10 years, if not further, as well as ongoing monitoring every 6 days. And that wide area capability, so not just necessarily one asset, but a whole suite of assets can be monitored using the same technique and have the same alerting system. So thank you very much.
That was great. Thank you, Jennifer and John. Okay, so I think we might move on to the next presentation, which is leak detection through satellite imagery, a case study from the Isle of Man. And it's going to be given by Tali Bartunsky, who's the product marketing manager at Assetera. Tali?
Thank you so much, Ian. So hi, everyone. Thanks for joining. I'm Tali from Astera, and today I'll be walking you through a recent case study with Minx Utilities from Isle of Man, where we used our satellite-based technology to help them reduce water loss. So this is a really great case study of how remote sensing can support water utilities with limited resources. And I hope you find the results as impressive as we did. All right, so let's begin. So for those of you who might be new to Astera, what we do is we specialize in using satellite data to support water infrastructure management. So basically what that means is we help water utilities find their leaks, hopefully before they surface. We do that by using L-band SAR satellite imagery, which is really good at detecting underground moisture. So this advantage really lets us scan the entire network from above, up in space, and pinpoint on the ground where leaks are most likely happening. We've helped locate over 175,000 leaks across the globe, saving more than 640 billion gallons of water and reduced greenhouse gas emissions along the way. So the impact is real, of course, both environmentally, but operationally as well. So just a little bit more about the technology and how it works exactly. So as I mentioned, we're using L-band synthetic aperture radar, SAR, which can penetrate through soil, vegetation, tree cover, etc. So this really gives us the ability to detect underground leaks, even in hard to reach or heavily built up areas. And the radar, together with our Astera proprietary technology, can pick up the differences in moisture in the ground, specifically from treated water. So we can overlay that data with the utilities pipe network. And from there, we can highlight where there are likely leak locations. Once that's done, our utilities get their results via our EODiscover SaaS platform. Their field crews can also access our app to collect and report data in the field right from their phones or their tablets. So we really provide a whole end-to-end solution. So as I said, the benefits of us using L-band SAR, the technology covers the entire pipe network. It can find leaks underground, even if they haven't surfaced yet. And ultimately, it's helping water utilities shift from a reactive approach to a more proactive one. So really sending crews out to catch problems before they get out of hand to the point where customers are calling in and they can prevent that expensive repair, emergency repair, and really get in earlier. And since the technology works in all types of weather and on many terrains, it's really a very beneficial way to prioritize those investigations, those repairs, and really make the most for utilities who have very limited resources. All right, so let's jump to the case study. So we worked with Suez, our UK partner, on this. They really helped us bring the local knowledge and the operational support to help implement the technology on the ground. And Manx Utilities, for those who don't know, is the water provider for Isle of Man. They provide many things, this electricity, gas, water, wastewater. So they're a pretty essential piece of the island's infrastructure. So Manx had quite a few challenges. So first off, they experienced a lot of severe droughts, which of course pushed water conservation to the top of the priority list. Also, in terms of their demand, the Isle of Man has one of the highest per capita water usage rates. And that, of course, spikes during the TT races. So there is a lot of demand for water. The system itself is a bit complex. There's hilly terrain, no metering, high pressure. So it makes it harder to really find, manage, and detect those leaks. And lastly, their leakage accounts for about 25% of their total water production. So that's really a major loss to the utility. And on top of all of that, they have a very, very limited team. They have just one engineer and 2 leak technicians to investigate. So with those challenges in mind, why did they choose Astera, our technology? So Minx partnered up with Suez, and they brought in Astera's satellite-based leak detection solution, which we call Recover, to help them really tackle these challenges that they were facing. And satellite leak detection was especially valuable on the Isle of Man, where the utility is geographically pretty isolated. And as I mentioned, they have very limited boots on the ground. So by giving them a clear picture of where the leaks were likely happening, we were able to help their team focus with the limited resources that they had. So instead of wasting time looking for those leaks, trying to figure out where they are, they could now use their time more effectively. They could actually see where they are. They could go to certain locations, and they save a lot of time by finding, fixing, and repairing. So as you can see, we had some pretty successful results. The satellite scan covered about 1,000 kilometers of their pipe network. It included 27 DMAs that had a history of high leakage. And from that, Minx was able to investigate 173 points of interest, or like kind of highlighted pipe segments that we provide to them. And from there, they were able to confirm 113 leaks. And they did this in quite a short time span, just 3 months. So that translates to a detection rate of about 1.5 leaks per kilometer, just over 3 leaks per crew day, which is really high considering the very small team and how much ground they were able to cover in such a small amount of time. And I think the most significant result that they were able to see is they saw a 5% drop in the leakage rate per property, which actually for them results in very significant savings. And because of these successful results, Minx has decided to make satellite leak detection a standard part of their strategy. And they've told us in Suez that really this approach has been a key factor in helping them reach their lowest ever leakage levels. And that's just not a one-off success. It's become part of how they're going to operate moving forward. They've said it themselves. They believe in the technology. They've seen the benefits that it provides, and they're excited to incorporate it into their plans moving forward. So thank you for listening to that case study. If you have any questions, please feel free to drop them in the chat, and hopefully we'll get to them at the end.
Yeah, that was really interesting. Thank you very much, Tally. Brilliant. Yeah. Questions? Yeah. If you have questions, could you put them in the Q&A box at the bottom? So certainly on my screen, at the bottom of my screen, I've got a more 3 dots. And click on that, and then the Q&A box will come up, and then we'll pick them up in the discussion at the end. And also, if you can give a thumbs up to any questions that you find interesting. So I think we're going to move on to the final presentation, automating the use of spatial data in water utilities by Jack Lonsdale, who is the discipline lead for Geospatial at Stantec. So Jack.
Thanks, Ian. Cool. So make sure I can control the screen. Perfect. Back one. So I'm just going into scripts. Cool. So yeah, so the previous presentation we sort of looked at today, we've seen some really powerful examples of the insights that are driven from the spatial and Earth observation data, and obviously seeing some really impressive innovation in this space. But I wanted to sort of present today about sort of the unsung hero and sort of speak wider about how mature systems that can come about that enable sort of effective, reliable automation. create resilience and adaptivity of the processes you sort of put into place. And actually, what's really required to leverage new emerging technologies, such as this AI thing that's sort of floating about. So I'm going to speak about it from the perspective of myself as a consultant in regulated UK water, and what sort of things we're putting in place as a foundational approach to spatial data. So the foundations. So naturally, I'll start with the obvious place and talk about food, and why wouldn't I on the spatial data webinar? But my analogy is that the best ingredients in the world can come together to create really incredible food. But it's the kitchen itself that earns that Michelin star. You associate the best kitchens in the world with being well-oiled, organized, efficient, and it's those special places that can turn potentially basic ingredients into something really special. Anyone can take finest ingredients and turn it into something that's amazing, but it's that places that can turn substandard stuff from the outset into really sort of powerful outcomes. So that analogy can be applied to our approach to spatial data. And what's often overlooked is those foundations, how we obtain, evaluate, cleanse, and store data. And from my experience, I'd hazard a guess that everyone in this webinar has received a late email with an Excel attachment called something like project data version 4 final, or been told, Claire's got a copy on her desktop, go ask her for it. And that is sort of like an element of acceptability sometimes. We're all working sometimes to pressure timescales, and sometimes that data is viewed as, binary. It either is data or it isn't. But there's a lot of subtlety that is captured between those two extremes. So what are those foundations though, and how can we actually apply them? Well, really its core is managing both the content and the context of the data we used, and that does apply to both spatial and non-spatial. And it's also how we store and record the files themselves. So some outline foundations are things like a central data environment. So assume whether that is cloud-based, server-based, but essentially everyone is using one version of the truth, that if there is data to be used for a project or a task or even an organization, that it is that one version that people are using that is well maintained and managed. Thinking then about the standards we apply to those data sets. So using conventions of headers, so you've not got Excel with columns down to ZZ, and then they're all a bit all over the place. So we have standardization of headers, the data types you're using, the formats that come through. Foundational assessment of things like accuracy, completeness, timeliness, how often does this data change? How dynamic is it? Talking about some of the previous presentations that, it gets these updates once a month. How do we actually respond to those changes? Looking at the source of that data, is it from, first principles collection on the ground? Is it from recognized government published data sets, or is it something someone's got squirreled away on a hard drive somewhere? And also that criticality, what is that data going to be used for? What insights are you driving from that? Is it regulatory? Is it something with a legal requirement? Or is it a pilot proof of concept? So we think about the levels of what this data is used for. And that's wrapped up with responsible owners and governance workflows so that someone is accountable for that data to actually undergo assessing these things, keeping that up to date, and make sure that's evidenced. So I refer to it as sort of building a spatial data architecture, so beyond the use case of the data itself. So to keep with sort of analogies, if you've got those foundations in place, then you can build something on those foundations. But the maturity or the depth and strength of those foundations, it depends on what you're trying to build on top of it. Grand palaces and skyscrapers require so much more underneath the surface than a garden shed. So that's focus on that outcome. What is that data used for? Organization shouldn't be for the sake of it, and neither should governance, but it's all down to that almost criticality of the next steps you're trying to use on. So if it's something very, in my world, if we talk about leakage, that's very much regulated. There's legal targets to try and meet for those. That outcome is very critical, and therefore more time should be invested in the front end foundations. So, when you've got these foundations that you want to apply, you then apply that to any information or data sets you receive, spatial or otherwise. So it's understanding what key unique identifiers might apply to that data. Is it all about the same asset, which one team calls one thing, another team calls another? Has it got a unique identifier? Is that common between systems, or does some work have to be done to align those things? A reiteration that prioritizing one version of truth. You don't want someone to be using a version of the GIS asset network from 2023 because that's good enough, whereas some teams are using a more up-to-date version. Understanding the linkages between those data sets. Is that based purely on their spatial location, or is it down to an asset level, or potentially an owner or a responsible party? And then make sure you go through those steps to cleanse that data. So receiving it in, ensuring that it meets those standards of data types and sort of column headers and what formats they're in. How is it organized within your system? Is it placed into a cloud sort of storage? Is it using a GIS online platform, or is it purely based on desktop? And then cataloging that. So make sure that's got a almost repository of an input register that has all this information in, that's accessible to the project teams that's trying to use it. And it lends me to something I speak about quite often, which is, well, so what? Everyone likes things to be neat and tidy, but does it affect the outcomes? And what I've seen over the years I've delivered these sort of data-based projects is that it really does enable some key outcomes. So a big one where we try and use things like extract, transform, load software, or things like, if people use ArcGIS, things like model build and trying to do stepwise process, it really allows you to leverage automation that's resilient. So if you're setting up in such a way where you are confident of those standards your input data is meeting, then the automation that follows that starts from that standard. So therefore, if you're sent a different version of that data set, you have a standard to relate back to, such that any processes that use that data going forward will be consistent. And then you're not tied up in knots where errors come about because the data sets that drive things have changed. And then through that, the change management of stuff, again, having that standard to relate back to allows you to update and account for any changes in data sets, and therefore how it pushes through the project. And it's very much aware of what those changes would be and how they have a tangible impact on the outcomes. For myself in a consultancy where we align to quality assurance ISO standards, that really clarity of what has been done to data sets and then what are they used for to drive outcomes enables really smooth auditability, allows you really standards of quality assurance and ensuring that any outcomes you do derive from that data are aligned with the maturity and the quality in the data you receive. Again, speaking from sort of a consultancy setting, very often we hand over these solutions back to client or back to regulator. And therefore, when you're doing that, having everything well organized and documented allows someone who hasn't been involved in the development of that solution to understand it, take it over, and create efficiency when ownership changes between process. And I like to then think of it of like systems thinking outcomes. So very often where we have very sort of strong drivers that are linked to certain elements, whether it's leakage, whether it's whether it's water quality, whether it's customer minutes lost and things like that. Organizing things in a way that has that connectivity and that cleanliness allows us to think about things on a more of a systems level. So rather than thinking about leakage from the perspective of a leak, you're thinking about the overall quality of the assets that drive that. And are we observing sort of wider impacts such as water quality or turbidity in that because of the quality of the asset itself, which is also driving leakage? So you think about how things interconnect and create a more broader and systems-based approach to the outcomes we're trying to drive. And I get in there as well that I mentioned at the start, this whole organization and data architecture-based approach both supports artificial intelligence. I think everyone's aware of when people have used ChatGPT or Copilot and it's made things up or hallucinates, as they put it. Any artificial intelligence or large language model type approach, it has to rely on data that trains it or feeds it. And if that underlying data is inaccurate, low quality, or not well managed, then the outcomes you get from these sort of approaches will also be that. It's an age-old principle of garbage in, garbage out. and that does apply at all levels of technology, and especially as we go towards sort of an artificial intelligence approach. But fundamentally, it can also support the other way around. So the developments we've made in AI can actually do a bit of this legwork by, if you compare two data sets that have similar references or similar IDs, you can do that initial pre-screening and say, can you look for the similarities and give me the closest matched, for example, rather than trawling through rows and rows of data set files. And I want to sort of close with a few sort of case studies that I've seen. So an initial one where this sort of approach really creates efficiency and value by doing it at the front end are things in our drainage and wastewater management plans, DWMPs, or water resource management plans, WRMPs, which are almost master planning for future design horizon, look at how we can generate resilient clean water supply and wastewater networks across our study areas. So it's long-term strategic planning. It's across entire company regions and catchments with multiple drivers, different time horizons, considering climate change, different scenarios, and it'd be very easy to get lost in just the detail behind each one of these things. But the requirement is this to have a consistent look forward on this systems-based thinking. And there's a requirement to review and respond to meaningful change within this. And the worst thing I think you can do in this space is have to throw it all out and start again anytime there's a meaningful change. So setting these systems up for success allows us to manage this as almost a live plan going forward, rather than viewing it in this traditional start to end approach of a project. It's then becomes cyclical. And therefore, when we have tangible changes to data and we've leveraged automation, those change cascade through to the outcomes you're driving from that. And really importantly, for those who have been keeping up with the review of the water industry, the Cunliffe review that happened really recently is going to drive quite meaningful change across the industry. And the whole concept of an interconnected long-term strategic plan is one that's here to stay. That direction of travel is really well promoted to go down that systems thinking approach to better value and better efficiency in the industry. Another case study, more so general organizational efficiency. So if you have a cloud-based infrastructure that a lot of people invest in, it allows setting this up with the right sort of approach from the outset, allows us access to client and internal GIS information, but doing that in that consistent and efficient way. Again, people in an organizational setting are working from a single version of truth rather than even just a task or project setting. Storing it in a cloud-based system also reduces the need to download and re-request data unnecessarily, leveraging things like APIs to get data at source. The carbon footprint that's associated with data and things like data warehouses and things like that is becoming more and more prevalent, with the water needed to drive that and the energy required for these. So little changes we can make as an organization to reduce the need to download and re-interact with data that we can manage at source is a really powerful thing. And also manage at this level, you then get into those considerations of security and appropriate metadata to reach standards. So allowing, again, yes, we've got this single source of truth of data, but does everyone need to access that? Or can we lock it down to certain groups, certain responsible owners? And again, that's all managed at source, because as soon as a data set leaves via an email and goes to someone, it's uncontrolled. You don't have any control of what happens. Past that point, yes, you might put appropriate caveats in an email, but ultimately you don't have control at source, and it could be used in manners for which you had no intention. And it's allowed us to, for myself as a geospatial lead in Stantec, to actually create custom tools and workflows, which we can leverage automation from connected managed data sets. So an example I've got on screen is where we use agreed base mapping data and overlay things like soil groups, road widths, OpenStreetMap information, proximity to water courses, and presence of a utility network underneath to understand and prioritize sustainable drainage features. So based on that connected data sets, we can generate those insights to meet some of the challenges from AMP8 and also through the challenges of low carbon solutions. It becomes, because you've got this catalog of data at the front end, a one-click solution. You draw a box where you're looking at, you click go, and it does what it needs to do because you've put that effort in the front end. And these solutions are based on sort of live and catalog data sets within our infrastructure. Changes that happen to those data sets drive through to changes in the outcomes of the tool without necessarily having to change the process analysis underneath that. And you see that then in some of the information you can drive from that, having really consistent outcomes across a study area, which you've got a couple of examples on screen, distance to different systems, distance to watercourses. That allows that really quick interaction with data from people who aren't necessarily that GIS savvy. They can get that one-click pop-up of information to help drive, the decisions and the outcomes they're looking at. And it's the same thing in maybe like where we do have to consider grey storage solutions. We can use these connected data sets to drive this optioneering process. So the example on screen is looking where, okay, I have a particular overflow asset that I'm looking to put grey storage at. Where could I place that storage tank location based on the proximity, the ground land use and things like that? And how can I connect that up? And what does that elevation profile look of that connecting pipework, for example? So to summarize in that, whilst sort of what I spoke about is not a specific use case of spatial data, I think the unsung hero in getting those foundations right, seeking at an ambitious stage organizational change to how we manage spatial data, ensuring that actually these principles are not a nice to have, and that our project teams and our outcomes-based work does consider those foundations and how we build them from the outset, then leverages massive efficiency at the back end and increases the confidence and increases the maturity of the insights we can gain from using spatial data. Thank you.
Thank you, Jack. That was really interesting. Brilliant. Brilliant. Okay, we're going to move on to the Q&A session. So I would invite all the speakers, if they could turn on their cameras and the microphones again. So we have received a question at the moment. So if you haven't submitted questions, then you are welcome to do so. It's a good time to do it. If you can put them in the Q&A box, that's really helpful for us. And the first question from the audience at the moment is from Stephen Leroy, and it's a question for Tally. So were the leakages on the Isle of Man freshwater leaks, or were they also grey water, wastewater? And if they were also included the latter, has been any correlation of the leaks on local water, groundwater quality impacts?
Yeah, that's a great question. So for this case study specifically, we worked with Manx on potable water, so treated water that was in the ground. Astera does provide wastewater services, but for this specific project, that's not what we explored with Isle of Man. But if you have further questions about any of that, then you're welcome to reach out to me, and I'm happy to tell you more about that.
That's brilliant. Thanks. Thanks. Okay, I might ask Jennifer and John. I might go to them. Could you what do you think are the challenges with acceptance and uptake of Earth observation technologies in a water utility company?
Okay, I'll have a go. So I think in terms of limitations, it's mainly the data sharing and usability of wider sort of user groups within the business. Obviously, there is an element of people getting used to using the data, but also when you're comparing sort of data types, they don't quite correlate exactly compared to kind of like a like-for-like comparison. So it still requires some sort of interpretation or sort of training to actually understand that. So then it makes it a bit more difficult to share with a wider group rather than just within a sort of a group of geotechnical specialists or surveying sort of specialists, really. So yeah, the improvement would be to, in effect, sort of integrate that more widely and make the data easier to use.
Yeah, I mean, that was something Jack touched on in the end, and I thought that was an interesting point. Yeah, definitely. Jennifer, sorry, do you have anything to add to that?
Yeah, I think John said, well, there are quite a lot of nuances to interpreting INSAR data, so there's always that learning curve when new users or new applications use it. I would say in the dam monitoring space, we've seen a huge uptake for tailings dams over the kind of last 5 years for INSAR monitoring of those. So I think it will get there, and how it's accepted in the tailings fields and the water utilities will come in the next few years.
No, thanks for that. Yeah, absolutely. No, that was a question on tailings dam, so I'm glad you tackled that. Thanks for mentioning that. Jack, I was going to turn to you then. So, how do you approach these data principles with clients and customers who aren't perhaps so digitally mature? How do you tackle that?
I think it depends. So I go back to the analogy of what are they trying to build. So we'd sort of try and approach it from, is it relevant to apply some basic things on a task level? Is it a project level, or is it sort of that, are they looking for organizational change? But I think having sort of really meaningful visual, so you go back to the traditional how you're producing GIS outputs and mappings and things like that to sort of say that narrative, and obviously then making it something that's meaningful to what they're looking at. So within the water industry, wastewater and clean water are still quite separate in the language they use, the context as they think about. So to make sure you have a really meaningful example in their language that explains what you're trying to do, and then you sort of get a feel for at what level do you want to apply this to, and therefore and then what systems their organization has access to. So well and good building on our systems if it's quite mature, if you then can't have that handover of outcome, and then just walking it through with them to make sure fundamentally it's in a language they understand, drives an outcome that they're comfortable to adopt, and then potentially the right thing is just to set that groundwork, just as a little demonstration of what can be done. And quite often then they come back to us and say, oh, we really liked what you did in that particular project. Can we apply this wider? And then we start talking about the strategic planning type level that we're seeing in things like DDMPs, WRMPs that I spoke about.
Yeah, no, it's a good point, because a lot of the time people just don't know what they don't know, do they?
Yeah.
Until somebody explains to them what's possible with the technology, they just aren't able to envisage it. No, that's really interesting. Okay, right. There's a good question from Dave Hughes. I'm not quite sure who I'm going to ask it to, but so he's asked, could aperture radar be used to track ground movements and therefore predict future volcanic eruptions and earthquakes?
Yeah, I'm happy to take that one. Yeah, short answer is yes. SatSense, our co-founders actually, Professor Tim Wright and Andy Hooper from the University of Leeds, they're part of this COMET group, a UK Centre for Observation and Modelling of Earthquakes and Volcanoes, and very much INSAR started for monitoring earthquake and volcanic movements. So I'd encourage you to check that out. As a company, we actively do that in New Zealand, where we work with the New Zealand Geological Survey, essentially GNS science. But typically the volcano and earthquake monitoring side of SAR sits more in the academic community and with the geological surveys.
No, brilliant. I guess it's not something that comes up in United Utilities very often, John. Yorkshire's got a lot of problems, but I don't think volcanoes is one of them at the moment, is it? Right, Tally, I was going to ask, can they detect changes over time? And if so, how can the utilities rescan of an area to monitor improvements and emerging issues? Could you maybe talk us through a little bit about something about that, please?
Yeah, absolutely. So for us specifically, we of course would encourage our users to do multiple scans a year, but of course, for every utility, it's very dependent on budgeting. It depends on their resources. If they have a team that's available to be going out so frequently to be checking after every scan. Of course, the advantage is that with leaks being under the ground and not necessarily surfacing right away, as they get bigger and bigger, then they become more and more problematic. So of course we like to catch those issues earlier rather than later. So with that additional scanning, you obviously can see the changes that are happening. It can be picked up as they get bigger, or or as they become more prominent, the satellite signal will probably pick it up. So it really depends on the utility and what their like resource limitations are, but definitely possible and definitely something that we encourage our users to do.
Yeah, no, absolutely. I mean, for me, that's the fantastic trick that the Insight in general can do is just that change detection. You know, I'm looking after geotechnical assets, and so it's rates of deterioration I'm interested in, but being able to quantify those changes, that's amazing.
Yeah.
Okay. Right, I've got a question for John from Charlotte Walker. Thanks for the question. John, you discussed several benefits of using Earth observation technologies, but which one provides the most financial benefits for water utilities companies?
So I can give you a bit of a nuanced answer to that. Effectively, obviously, with regards to obviously leakage detection, you're making potentially a lot of benefits by finding a lot of leaks in different areas and saving resource times, and also getting there before problems are exacerbated. So that obviously you kind of like a build up of benefits there. But then with the sort of the INSAR and the monitoring, it's one of those where you're kind of, if you're proactively monitoring your assets, you're avoiding incidents, but you don't know in terms of, like, say on a river erosion rate, you're trying to avoid an incident which could potentially be very costly, and the damage in terms of our environmental cost and also reputational risk. So saving purely one of those incidents can potentially generate one big saving in avoiding that incident completely. So the benefits are, yeah, you could potentially get one huge benefit, or you could get general operational savings through use in a lot of instances, if that kind of makes sense.
No, I know. No, it does. It does. No, that's a good answer. Thanks. I mean, I feel the same thing as well. I mean, obviously, looking after sort of road network, I get asked all the time about how many landslides we have in the network and things like that. Is what I can never answer is like how many landslides we've prevented by doing, timely interventions, and that's really where the savings are. You know, that's what we've done.
Yeah,
So
and
I mean,
it's always and it's always difficult. You're effectively trying to quantify something that never happened but potentially
Exactly.
stops it, and then it's difficult to sometimes get the kind of like the leverage off of that in terms of the investments and stuff, because you potentially save some money that you didn't have to spend, but you can't quantify it.
It's hard to put into a business case. It very much depends who's asking, depending what question, what answer I give. Okay, there's another question in the chat from Farnoosh, and it's actually quite a general one, so I might go to Jennifer. And if you could possibly say something about the types and the source of the satellite images that you use in the projects, that's quite a good general question.
Yeah, so I guess specifically for that dam case I showed in the presentation, that was Sentinel-1, so European Space Agency satellite. But depending on the project, we use pretty much all SAR satellites that are out there. So I also showed an example, that Birmingham reservoir that was using high-res TerraSAR X as the satellite that's operated by Airbus and the German Space Agency. So yeah, we're, I guess, satellite agnostic in terms of what we use. The wavelength and the satellite depends a lot on the project and the environment. For example, whether it's a vegetated slope, or if you're monitoring infrastructure, you might want to be even more precise and have better spatial resolution with X-band. So yeah, really any of the SAR satellites that are up there.
Brilliant. No, that's cleared that up. Thank you. Thank you. Okay, Jack, I wanted to ask you actually, so what is the momentum you're seeing in the regulated water industry with digital technology? What do you think the direction of that is at the moment?
I think we've seen in the last, so for those who aren't in regulated water, we work in asset management periods. So we just left AMP 7, which is 2020-25, and we're now in AMP 8, 25 to 30. I think there was quite a watershed moment based on, trying to address the unknown unknowns. So a big thing that people may have seen in the industry is the billions of investment going in the next 5 years to reducing spills from things called storm overflows, which are essentially release valves in the system where heavy rainfall overwhelms the system. Rather than it backing up into roads and homes, it has a release valve to the natural environment. Prior to AMP7 2019, really, there was no real understanding of how often these things were spilling, so to speak. And then through the installation of digital monitoring technology called event duration monitors, or EDMs, we basically got a handle on how often these were spilling, and therefore that unknown unknown became the known unknown became a known known. So we're essentially seeing digital technology now in monitoring as a big swathe of things. So tying up assets with live or semi-live information around them to really understand the depth of the problem we're seeing, rather than guessing based on models or based on anecdotal evidence. So by building that almost foundational understanding of the system, how it operates, whether that's as designed or not, we're sort of approaching that horizon of lots of information, whether you refer to it as Internet of Things, but essentially connected live or semi-live information around assets. What we're now starting to see is, well, what do we do with all this information? How do we make sure it's meaningful? How do we respond in the right way? How do we ensure that data is clean, fit for use? So we're at this watershed moment of the investment going in the next 5 years will both be putting in solutions where we have this confidence, but also getting that wider understanding, moving towards, we're seeing pilot studies and things like smart networks. So that's having everything within the network sort of speak to each other for that, like we're seeing the leakage side of it, that proactive maintenance, i.e. a blockage is forming, let's go deal with it now based on how quickly this thing is forming before it causes a potential pollution incident or a collapse or a pipe burst and things like that. So it's the monitoring that seems to be the direction of travel at the minute. But I think what we'll then see is how that informs solutions over the next sort of 10 years after that.
Yeah, no, that was brilliant. That's a good answer. Thank you. Okay, I was going to jump to Thali. Actually, I had another question for you. Do you want to say something about the main advantages using satellite scanning compared with the more traditional acoustic or ground-based leak detection methods?
Yeah, of course. So as I was talking about in the case study, the real advantages of the satellite scanning is that you're getting one shot of your entire network, right? And that's something that without being able to get that bird's eye view of everything that's going on, then the traditional methods are just these boots on the ground teams just walking the line, unguided, not exactly sure, where to find those leaks. So just listening everywhere and anywhere, and that wastes a lot of time, wastes a lot of money, resources. So by being able to understand where it is in your network, those problem spots are prevalent, you're able to prioritize it properly. You're able to allocate your resources in a more optimized way. And then it's complementary in the sense that at the end of the day, you do need the boots on the ground team to get out there with their listening sticks or with the acoustic or whatever it is that they're going out to check, and actually, physically go verify that it's there, and so you can fix it as well. But the satellite piece, that kind of layer or that tool in your toolbox is really, helping the entire process from the beginning so that you're not wasting your time walking around.
Yeah, no, thanks, Thali. I just on a follow-up to that then, I mean, it was a really good example that you gave from the Isle of Man there. Is this technology, is it more widely adopted in, say, Europe or America or further afield?
Great question. We are global. We have clients all around the world that are all using our solution. It's really aging infrastructure and leaking pipelines is something that's in the entire world. Every water utility is experiencing that challenge. So we're able to come in, and especially with the satellites that has global view of everything, we're really able to tackle it anywhere and everywhere. So that also gives us a leg up.
Yeah, no, great, thank you. And I had a question actually from John as well. Actually, I think it's a question for me really. When I think about the sort of regulated water sector, and I think about sort of an industry that's quite mature in its use of good asset management principles. I wonder if you want to say something about the integrating Earth observation data with existing asset management systems. Then I was wondering how you found that at UU.
So in terms of the sort of the data itself. It's feeding, in effect, it's probably more the other way around. So we've got our assets and we want to understand them more from quite like a large base of information. So like take the reservoirs, for example, you know, those are monitored very closely, and they're walked every sort of 48 hours. And then that, in terms of they obviously have an assigned supervising engineer, and then obviously there's an audited process to ensure that we make that we follow the prescribed sort of requirements under the Reservoirs Act. So obviously, like I said, 48-hour walking, you have annual reviews and then 10-year reviews, and these will kind of like pick up activities that we need to be undertaking with the asset. And then these kind of like then either from the audits or potentially what someone sees on the ground, then that kind of like initiates sort of further investigations, which then might take, say, the INSAR or the traditional monitoring sort of forward. Sometimes if you're going at it the other way, you might create a lot of false positives potentially, in terms of you know effectively you're just spreading yourself too thin, so it kind of ends up working the other way. So if you know you're comfortable with your asset, and it's functioning as it should, there are no concerns, then I think we've got so many assets that you would probably not look to do anything different with that. But always potentially, you know, effectively it's a case of risk versus expenditure. So the balance of that is always changing. So, you know, say if satellites get really sort of move on quite a bit in terms of like maybe the AI or the machine learning, and the cost and the improvements in the data get better, then I imagine that balance will change. So you will probably do more in terms of that that you know, all round data capture.
Yeah. Just out of curiosity, then, do individual dams have individual trigger levels set, or do you work in a more generic?
No, so in terms of like, if I just give like the monitor of settlement, so then we ban those into what's acceptable and what's causing, you know, what might cause concern. So say typically with the reservoirs, it's more than sort of 25 mil and up in terms of annual settlement rates, and then that obviously triggers, you know, it's gathering all the information. Do they have concerns on site? Has something caused that issue? You know, have we had a vehicle or something on site that might have come into contact with that particular monitoring point? So, you know, so it's looking at it on the round. It's not a case of just seeing a number and thinking, oh, that's an issue. There may be an explanation for it.
Yeah, it's not that simple. No. And Jennifer, then from a provider's side of things, like how do you go about trying to integrate your products then into like an existing client's asset management system? You know, what do you need to know from your side of things?
Yeah, it's really dependent on kind of how sophisticated the client's existing asset management and GIS software is. So, for example, with Network Rail, we deliver INSAR data via API straight into their internal GIS system. So therefore, they have everything all in one place, and it's kind of on their side. Lots of other clients don't have that capability. So then we have our own, you know, web-based GIS portal where clients can interrogate the data themselves. And sometimes clients don't necessarily want to get into the depths of the data, and they just want that email notification if something has changed, and then maybe they'll have a look at it. So yeah, from the provider side, we're very flexible and offer a lot of different ways to do that. It's really trying to, we very much try to build in with what's already there, as opposed to giving another software, another system, another something to use when that can be avoided.
Yeah, no, that's interesting. I'm very much a client who just likes an email to get told when I have to do something.
Yeah.
But, okay, right. There's a couple other questions actually in the Q&A that I'm going to let anybody jump in who knows best about this. So can INSAR, SAR, and other technologies be used to monitor SUD's health? So I'm gonna open that to anyone who wants to try and tackle that.
I can probably tackle some of it, but maybe
Yeah.
not all. So I would say kind of indirectly in this case for SUD's health. So I can think of a few different ways. So SAR can also be used for flood mapping. So again, and with that archive of data as well, looking to see, is it always, the same area that floods, and has that changed following perhaps a new SUDS implementation? In terms of INSAR for subsidence, I think that would be very much, like a long-term thing you might be looking at. Perhaps if one particular area is subsiding, the effectiveness of your drainage system may change over time if water starts to move towards that area that's subsiding. And the other component I can think of is soil moisture, which maybe Tali wants to speak to more, but again, that can be something you could look at changing through time. The soil moisture aspect.
Yeah. Tali, do you want to comment as well?
Yeah, so in terms of the SAR data, we have the ability to detect moisture in the ground. So as you know, that can apply to all sorts of different risk assessment areas, especially for water infrastructure management. That's something that we're also taking a look at, not specifically in this case with our Recover product that has to do with the potable pipelines. We do have a solution that caters to specifically to soil moisture monitoring. So yeah, definitely a capability specifically with L-band SAR that, as I mentioned, can penetrate through the soil and really get that good reading on what's going on underground. Definitely beneficial and can help.
Yeah. No, thanks for that. Yeah, soil moisture monitoring is something I'm really interested in.
I think there's, just take it from me, and on that point, I think there's also a role to play for good old-fashioned imagery, especially if you can get clarity of picture. If you've put in a subs installation like a detention basin that's designed to fill to a certain level, you can monitor that on time. Is it still filling to that intended level? Is it performing as designed? Because you can use back-end analysis from that to look at where that water level rises to in certain events. You can understand the depth to that, and almost sort of change that through time. When I think of a bit of back-end back-end automation, sorry, you can get some good insight there. We're doing just an example of where I think John spoke about it, how we can use AI and technology to auto-interpret things like satellite imagery and monitoring. We're launching a project that's looking at rack concrete. That's a problem for schools and gyms everywhere. And it's like, can you use how that, the makeup of rack concrete to auto detect where it might be across sites, and using almost like machine learning, so it picks up imagery or otherwise to try and classify that. So we are seeing some emergence there, and I think sometimes we're just a little bit limited of how we can try and train a model to do things. So it'd be really interesting to use these various things on different SUDS health, and it could be something that does emerge over the next few years.
Yeah, no, that's really interesting. I mean, obviously people talk about AI all the time at the moment, machine learning. I guess that's a good example of when I hear people talking about AI, particularly in terms of geotechnics, a lot of the developments seem to be around about productivity and efficiency and just doing things slightly faster. I'm quite interested to hear about things that weren't possible before. And I suppose that's a good example. I mean, I don't know if you've got other examples, perhaps, of examples of using AI, machine learning, to really kind of answer questions that just we couldn't do. We couldn't answer them previously.
Yeah, and no, massively. And I think the headline AI is what people need to look around. Headline AI is these chat GPTs, which are essentially just language models that are regurgitating information in quite a conversational way or providing structure to stuff. But there's still a lot of a place for more old-fashioned but less accessible machine learning on stuff like where we're looking at benefits realization for clients. So they're looking at solutions they've put in that saying, well, over a time period, what will this reduce my spills from storm overflows by without that time period occurring? So it's that predictive analytics. And that's then looking at, okay, well, this is how it responded prior to solution to a certain rainfall event. This is how it responded post-solution, you train the model on those differences and say, okay, what if I have this whole year's worth of rainfall or these similar events? And it'll say, oh, I know the difference between something you've told me. I will predict the difference on something you've not told me. And then getting that foundation and uncertainty within that. And that's not something you could really stare at long enough and come up with the answer. So it's that ability to train something up. But in the same principles, things I spoke about, it's only as good as the information you train it. So if you give it a best guess to train it on, it will only ever produce a best guess. So there's a lot of considerations on how you set them up for success. But yeah, we are starting to see it emerging, and us as a company are really investing in the Copilot suite for the efficiency and access to information built on our internal systems, but then also how we're using what's something called agentic AI, or create an agent which does it makes its own decisions, so to speak, but again within the box you build it in. So we're doing it, for example, where we're doing solutions that have to comply with guidance. You know, there's a legal requirement and guidance for drainage and wastewater management plans. So where we've produced a document, having that AI agent look at our document, look at the guidance and say, here's where it matches up, here's where you have some uncertainty, here's where the gaps are that you need to address. So it's now allowing us to do sort of a more sort of deep dive QA as well. So we're seeing it, you know, emerge in a few different places personally.
Yeah. No, we're running out of time, but I'm actually really interested just to get Jennifer and Thally's opinion on that. Actually, from a provider point of view, just we could run a whole topic, or maybe we should one day on AI in this. But from INSAR point of view, what's the headline changes from AI? What's going to be the impact of AI on INSAR?
Yeah, I mean, I think it can be very powerful, but I think Jack hit the nail on the head with the terms of the training data set being a lot of the time the issue. So there's two examples that we've worked closely on, and one is using INSAR to detect pipe failures, and we've done that with water utilities and had that pipe failure data set given to us. But the data set on failures is of course limited, because sometimes they're not found until months, if not years, after the pipe failed, and you don't know that time gap or the cause of the failure. Was it some kind of manual construction work where, you know, INSAR's not going to detect that, there's not going to be a precursor. And then similarly on the slope stability side, again, it's having that record of slope failures and categorized into, was that a slow slip event that then accelerated and failed, or was that a sudden rainfall event that triggered it? And again, we wouldn't see a precursor with INSAR. So it's still very much a work in progress, and definitely when we're scaling to using it on a network wide approach, it has to be the way to go, is AI and machine learning.
Yeah,
but
absolutely.
you need that good on the ground data to help train and classify to make it work successfully. So it'll get there, but it's still work in progress.
Yeah, no, very interesting. Thally, I wonder if you want to add anything to that about.
Yeah, I think it's really echoing the same sentiment, but you know, we're finding that it really just increases our accuracy, because let's say in our case, every time we have a confirmed leak on the ground and that data is fed back into our algorithm, into our system, the machine learning is just constantly learning and constantly improving, so that with each output, you know, it's learning, it's getting better, it's getting more accurate. And so the quality of data that we're able to provide to our end user just, you know, continuously improves as time goes on. So for us, it's an amazing advantage.
Yeah, brilliant. Actually, while you're on Thally as well, we had another question from Farnoosh. So thanks very much for the questions. But he was asking about Acetera and your collaboration with universities and research. Are you doing things in that area at the moment?
Not actively, but it's something that we've definitely touched on in the past, and something we're definitely open to. So I'm really happy for anyone to reach out to me and ask more about it, for sure.
No, brilliant. Oh, that's really good. Okay, I think I'm probably going to bring the Q&A session to a close just now. But thanks everyone for who submitted questions there. That was really interesting, and thanks everyone who joined today's webinar. Thank you to Jennifer and John, Thally and Jack. Thanks for your valuable contributions. So we will circulate a link to the speakers' presentations if they're okay with that. And we'll also endeavour to respond to any questions not covered today. So if you think of anything additionally that you would like to know, please get in touch with the Syria team. It's not a problem. So I think we are going to move on to the feedback poll. So we're keen to hear about your webinar experience, and we'd be grateful if you could complete this short poll that was popped up on your screen, hopefully. And if you want to receive CPD for the attendance here, you need to complete the poll. But I don't think it's going to take very long. I think it can be done quite quickly. So while you're doing that, while you're filling it up, I was just going to say thanks very much for dialing in today. I mean, just thinking about sort of themes that have kind of gone through this. I mean, a lot of it was talking about sort of uniform data sets and sort of single sources of truth. And as an asset owner, having a single source of truth is the ultimate prize, and what we're trying to do. Any asset management system needs that. I think another strong theme that came through for me from listening to everyone's talk was that this idea that like the science is absolutely proven, that all the Earth observation work that they're doing and the INSAR, it's a mature industry, and these techniques work. This is not, this is not a brand new, radical technology that's never been tried before. It really does work. And there was certainly, I quite liked hearing about how people are actually trying to integrate the data with sort of existing systems. That's another thing that I'm really keen on, is to try and get any new data that comes in to work with existing systems. That's one of the most important things I think that can happen at the moment. So I think the last few slides, I was going to just talk a little bit about becoming a member. So just a few slides about Syria news and upcoming events. As mentioned earlier, we're always keen to broaden member base for the geospatial community of practice, and we're always welcome to new organizations signing up. So members benefit from brand exposure through contributing to the industry-wide knowledge transfer and demonstrates leadership. And there's an opportunity to present at events such as today's and showcase case studies and participate in Syria's wider networking events. So being a member also allows you to influence the scope and the direction of the community of practice, so the activities, and work alongside other members. There is an annual subscription fee, which scales to the organization type and size. So if this is something you'd be interested in and pursuing for your business, could you get in touch with Jack Young, who leads this from Syria's side of things? He's always happy to talk through anything that you have. And just finally, upcoming Syria projects in 2026. Again, please contact Jack for more information to be kept up to date. They mentioned tunnel infrastructure management, climate change and contaminated land, piling guide, and asset management for blue-green infrastructure. I have to be honest, I'm not quite sure what blue-green infrastructure is, but it sounds interesting. So that's it for this webinar at the moment. Thanks very much for everyone that contributed, and thanks for attending, and hopefully stay in touch and hear about the next one that comes along. Thanks very much. Bye.